Welcome to Year 2, Pure, Chapter 10 about numerical methods. In this chapter, you'll be learning a few things about locating roots and different methods to locate a root. For example, when you talk about root, it's not about plants roots, it's not about the equation roots, the solution to the equations. So some of the equations are not, solvable or not solvable. They are solvable, but they're not factorizable, but they're not easy to work out a exact value. So sometimes it's easy to estimate a root, estimate a solution. So, and also iteration, something you've done GCSE, however, we'll be looking into a bit more in details, and a new method called Newton-Raphson and application modeling. Right, so first of all, locating roots. Recall, the roots of y equals f of x means a function of x, an equation are the values of x such that f of x equals 0. So you've learned this, what we call the factor theorem. Pure 1, chapter 7. Graphically, this is where the graph crosses the x-axis. Well, even Dora knows. If the function f of x is continuous and there is at least one root between the interval a and b, then we say f of a and f of b will have opposite signs. So we substitute f of a and f of b, substitute a and b into the function, they will have opposite signs as the graph crosses the x-axis. So you can think of it like this. Okay, so let's say, for example, okay, here are the roots, right? So here's the root. Now just look at before and after the root. Okay, just look at before and after the root. So you've got in here this part and this part. This is positive y value and this is negative y value. So sign changes. Same in here, before and after. Before is negative, after is positive. So positive y value. That's why we say they have opposite signs. One is positive from negative, the other one is negative to positive. Okay, as a graph crosses the x-axis, we can use the logic of sign change to determine the existence of roots between the interval. For example, the diagram shows a sketch of y equals f of x, a cubic graph. Explain how the graph shows that f of x has a root between 2 and 3. So what you can do in here is you can use the sign change method. So in part A, what we can do is we can substitute 2. So f of 2, substitute 2 into the function. So 2 cubed minus 4. I like to use a bracket in here, just in case of negative, plus 1. So put in a calculator, you should get this give you minus 1. And if you put f of 3, okay, 3 cubed minus 4 times 3 squared plus 3 times 3 plus 1, put in the calculator, you get a 1. So what you're saying here is there is a sign change. There is a sign change. So there is a root. There is a root between 2 and 3. So between 2 and 3. So this is an interval. This is an interval. Of between 2 and 3. You should have seen it in chapter 2 about domain and range. So between 2 and 3. Okay, so x equals 2, x equals 3. So that's how we explain sign change. Okay, the sign change, there's a root. Show that f of x has a root between x equals 1.4, 1.5. We can do the same thing. Okay, so f of 1.4, maybe I'll let you try it and put in a calculator. F of 1.4, f of 1.5, put in a calculator. You should get 0.104 and negative 1.125. Does not matter what the value is, as long as there's a sign change. Okay, so sign changes. So sign changes. There's a root. 1.4, 1.5. Okay, right, simple as. Right, so your turn. Okay, practice to show there's a root between 0.5 and 0.6. Pause the video, have a go at the question. When you're ready for the answer, you can press play. Here's the answer. Okay, straightforwardly, you have to show the values and say sign changes. There's a root. Simple. Yeah. Too simple to believe, isn't it? Right, so therefore we're looking into a bit more details. Okay, sign changes does not always actually work. Okay, we'll see why. Now, investigation 1. Can you sketch a graph of f of x equals 1 equals x? Pause video, we'll do it together. Okay, pause video. Okay, sketch a graph of y f of x equals 1 over x. Okay, here's a graph of y equals 1 over x. Work out the value of f of 1 and f of minus 1. So f of 1 is 1 over 1. F of minus 1 is 1 over minus 1, which is minus 1. So the sign changes. But could you conclude there's a root between x equals minus 1 and 1? Now look at the graph. Is there a root between minus 1 and 1? So between, let's say that's 1 and that's minus 1. Is there a root? No, actually there's no root. Why is there no root? Sign changes, but there is no root between x equal minus 1 and x equals 1. Because there is an asymptote at x equals 0. Okay, so even though the sign changes, it doesn't mean there's always a root. What it means is, if there's an asymptote, that means there's no root. So it does not always work. Okay, so the sign changes doesn't always work. I'll explain. Because even sign changes, if there's asymptote in between, you can see a sign changes in here from negative to positive, but there's no root. All right. Next one. Okay, investigation 2. Sorry about that. My logo actually is in the way of the graph, but you can still see it. Given f of x equals minus x plus 1 squared plus 0.5 and the graph is attached, work out f of minus 2 and f of 0. Okay, can you conclude there's no root between minus 2 and 0? So let you pause video. Okay, have a go, work it out, f of minus f of 0, and think about sign changes. Think about the graph, what's happening in here. So if you put f of minus 2, okay, you should get f of negative 2 as negative 0.5. And if you put f of 0, you also get negative 0.5. So what's happening in here? Is there any root in between? Now, no sign change, but the graphs tell us there are roots. So just because there's no sign change, it doesn't mean there is no root. Because if you look at the graph, there are roots. These two are the roots. Right? So minus 2 to 0. Minus 2 to 0. So what's happening in here? It means potentially there are even number of roots. So it could be 0, could be 2, could be 4, da 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 da. So what I'm trying to say in here is, for example, in here, I'm just using that graph as an example. Just draw it bigger. Here, minus 2 is negative, and that's negative. So these are both negative. However, there are roots in between. There are 2 roots. Okay, so that's the issue. So can you conclude there's no root? No, actually, there are two roots. Instead of 0 roots, you have 2 roots. They're even number roots. Next one. Okay, potential fallacy of sign change method to locate a root. So these are the potential fallacies. The first one. Okay, problem. The sign changes between A and B. So at A, okay, this is positive. At B, this is negative. But I'm going to type it out because my handwriting is very nice. Because, okay, so, but there are multiple roots between A and B. Also, okay, usually there are odd number of roots. So it could sign change, but there are multiple roots. Okay, there are odd number of roots. There's no sign change in A and B. Now, I'm using different color in here. You can see in here, negative, negative. So what does that mean? If there's no sign change between A and B, it could potentially mean, again, there are multiple roots between A and B. But if there's no sign change, we will say there are even number of roots. Okay, as we just looked at it before in the previous investigations. Now the last one. Sign changes between A and B. But, so in A, this is positive. At B, this negative. But if you look across the diagram, the graph does not cross over the x-axis. So, but there is actually potentially no root due to a vertical asymptote between the interval. Okay, and that's why. So in an exam question, they could ask you, sign changes, but you need to think about, okay, in terms of the roots, in terms of the graph, actually, what's happening there? Why is it? Does it always mean there's a root? Does it always mean there's no root? If the sign changed, does it always means there's a root change? Always a root between them? No. Okay. If there is no sign change, does it mean there's no root? Not really. Okay. Right. So example in here, let's have a look. The function of a graph, the graph of function, graph of function, f of x equals 54x cubed minus 225x squared plus 309x minus 140 is shown in diagram. A student observed that f of 1.1 and f of 1.6 are both negative, and states that f of x has no roots between the interval of 1.1 and 1.6. Now, if we look at the graph, 1.1 is here, 1.6 is here. So they're both negative, right? They're both negative. So explain to the reference, by reference to diagram, why the student is incorrect. Because, well, clearly from 1.1 to 1.6, are there roots? Yes, there are actually two roots, here and here. There are roots. Look like ghost. Doesn't it look like ghost? Boo. Anyway, so part A, well, clearly, okay, the diagram shows the curve passes through the x-axis, meaning there are roots between x equals 1.1 and x equals 1.6. So the student is correct. Okay. Part B. Calculate f of 1.3 and 1.5 and use your answer to explain why there are at least three roots in the interval between 1.1 to 1.7. Okay. So what we can do in here is, first of all, now calculate f of 1. So we know, so part B, okay? So let's calculate f of 1.3 and 1.7, just like question asked. So 1.3, put in a calculator. So 54 times 1.3 cubes minus 225, 1.3 squared plus 309, 1.3 minus 140. Now, I'll tell you a shocker how you can put in a calculator quicker. Now, if you have used the formula, the equation more than once and put a different value, this will be a quicker way to do. Actually, when we do iteration next lesson, this will become useful, so which I'll go for again. Anyway, so what we'll do here is, first of all, do not put a whole thing in the calculator. Just put 1.3, okay, and then press equal. So what you're trying to do in here is you try to store this value into the answer button. So what you're going to do now is you're going to use this equation, type this equation, but instead of using 1.3, instead of typing 1.3 every time, you put answer button. So replace it with answer button. So I'll do 54 answer cubed, 54 times answer cubed minus 225 times answer squared plus 309 times answer minus 140, 0.088. Okay, so that's 0.088. Now, next, you want to put f of 1.5, right? So f of 1.5. So instead of using 1.5, what you can do is you can put 1.5 equal. So that's your answer button, right? Then use your arrow to go back to the previous line, this one here, and press equal again. Your answer button in this display will now automatically refer to the 1.5. So press equal again, you get minus 0.5. That saves you a lot of time. And we know every second in exam is worth millions. So in here, so what do we know? So now what do we know is, so f of 1.1 is negative, right? So it's negative. F of 1.3 is positive. So sign change. There's a root between 1.1, 1.3. We can say this because we have the graph to help to back us up. Okay, not because there are multiple roots. Okay, there's a root between 1.1, 1.3. What else? We've got 1.5 haven't we? F of 1.5, which is negative. So what does that mean? So f of 1, so 1.3 is positive, 1.5 is negative. So that means again sign change. Yes, every time you do have to keep it writing sign change. The sign change. So there's a root between 1.3, 1.3, 1.5. And last but not least, 1.5 and 1.7. So 1.7, 1.7. Oh, the question did not say about 1.7, but I believe we should put 1.7 in calculator. So let's put 1.7 in calculator. So we can now that's why so we use AC. If we press on, you wipe out the previous history. So that's why I don't recommend students using on unless they want to wipe out everything in beforehand. So 1.7 equal. Go back to that line here. Press equal again. This is 0.352. So again, sign changes. Sign change. There's a root between 1.5, 1.7. So therefore, therefore there are at least three roots between x equals 1.1 and x equals 1.7. Now, why at least? Because have we checked 1.2, 1.4, 1.6? Have we checked 1.25, 1.35, anything between? No. So we can say, just for now, we'll say there are at least three. Okay. Right. So another practice. Pause the video, have a go at the question. Okay. When you're ready for the answer, you can press play. Well, here's the answer. So they ask you to sketch y equals ln x and y equals 1 over x. So we sketch a graph. So hopefully you do remember these basic graphs, the reciprocal graph and the ln x graph, which is like the exponential, but it's a vertical one, which is positive 1, positive x-axis 1. So the question wants you to show that the function f of x equals ln x minus 1 over x. Now you might be thinking, how are these y functions relate to this f of x? Because if you try and bring the 1 over x to the left hand side, you see 1 over x equals ln x, which are the two graphs. And that's why we look at where they cross over, where they intersect. So after sketch a graph, you can say there's only one root because the graphs only intersect once. When we say one root, we talk about the one solution. This is a solution to the function f of x, not the root, in here. Okay, we talk about this solution. Okay, this is a solution. So when you locate a solution, where's the solution? Well, we can use a sign change. So you can try f of 1.7, 1.8. So we do 1.7, 1.8. So you show the answer. You see sign changes. Therefore, there's a root lies between 1.7 and 1.8. And then part C, they want you, given the root f of x is alpha, show that alpha equals 1.763, correct to 3 decimal places. So what we do is we consider upper bound, lower bound of 3 decimal places, the 1.762, 1.763 of upper bound, lower bound, which is 1.7625 and 1.7635. So again, show sign changes. There's a root. So therefore, if we round these two numbers to 3 decimal places, we can say alpha is 1.763. And is there one more? Yeah, there's one more exam practice. Quite simple. This time, pause the video, have a go at the question. When you're ready for the answer, you can press play. So here's the final answer. Now you must write everything that you see on the board on your paper, or on your notes to get the 3 marks. You can get 3 marks. First of all, we show the values of f of 2.3065 and 2.3075. And then you will say sign changes, and then you have to write the final line where 2.307 correct to 3 decimal place. That's how you get 3 marks. Okay, and that's it for 10.1.